The book builds a universal JavaScript application in 3 progressive stages, and the starting point is deliberately simple: a pure client-side React app served by Express. No server-side rendering yet. Just static files with an API endpoint. The architecture is straightforward. Express serves a static HTML file containing a div with an ID of root. It also serves your Webpack bundle as a JavaScript file. The bundle contains your entire React application. When the browser loads the HTML, it downloads the bundle, JavaScript runs, React mounts to that root div, and your app appears. Your Express server also exposes an API endpoint, say, /API/articles, that returns data as JSON. Your React components use useEffect and fetch to call this API, get the data, and update their state, which triggers a re-render showing the actual content. This is a completely valid, production-capable architecture for many applications. It's what Create React App gives you. It's what every single-page application was in 2015 and 2016. But it has 2 real problems. First, SEO. When a search engine crawler visits your site, it receives that minimal HTML file with an empty div and a script tag. Many crawlers don't execute JavaScript, so they see no content. Your beautifully rendered article list is invisible to Google. Second, initial load time. The user's browser gets the HTML, then downloads the bundle, then executes it, then calls the API, then re-renders. That's 4 sequential steps before the user sees anything meaningful. On a slow mobile connection, that can be several seconds of blank screen. These 2 problems, SEO and time to first meaningful paint, are exactly what server-side rendering was invented to solve. And that's stage 2. Server-side rendering changes the contract between your Express server and the browser. Instead of sending an empty HTML page and making the browser do all the work, the server renders the React components to an HTML string and sends the pre-filled page. The key API is React.DOM-server.render-to-string. You import your top-level React component on the server, call render-to-string with it, get back a complete HTML string, all your components rendered, all the structure in place, and inject that string into your HTML template where the empty div used to be. Now when the browser receives the response, it has real content immediately. The user sees articles, headings, text, the fully rendered page, before a single line of JavaScript has executed. Time to first meaningful paint collapses to the time it takes to download and render the HTML response. Then the JavaScript bundle loads, React finds the server-rendered HTML in the DOM, and hydrates it. React attaches event handlers, initializes component state, and takes over as a client-side SPA. From this point forward, navigation happens on the client without full-page reloads, React updates only what changed. This dual-render approach is called isomorphic rendering or universal rendering. The same React components run twice, once on the server at request time, once on the client at load time. There's a subtlety worth highlighting: on the client, you don't call React.DOM.render, you call React.DOM.hydrate. This tells React, the HTML is already there, don't recreate it, just attach event handlers and activate state. If you mistakenly called render instead of hydrate, React would discard the server HTML and rebuild the DOM from scratch, losing all the performance benefit. The remaining challenge is data. The server can't call its own API over HTTP efficiently, and the client starts hydrating before it has the data. That's stage 3. Here's the hardest problem in server-side rendering, and it's the one that most tutorials gloss over: how do you get data into server-rendered React components? Your React components use hooks, useEffect fires after render, never before. If your data fetching logic lives in useEffect, the server renders the components without the data, produces HTML showing a loading state or empty lists, and sends that to the browser. You've added server rendering, but you're still sending empty content. You didn't actually solve the problem. The fundamental issue is a timing mismatch. Server rendering is synchronous. React calls your component functions, assembles the tree, returns a string. Data fetching is asynchronous, it requires waiting for network responses. You can't wait inside render-to-string. The solution the book demonstrates uses 2-pass rendering on the server. In the first pass, you render the component tree to identify what data each component needs. Components signal their data requirements through a static method or a configuration object, something the server can inspect without actually rendering to the DOM. The server collects all the data requirements, fires all the fetches in parallel, waits for them to complete, then does the second render pass, this time with all the data pre-populated in a store that the components can read synchronously. The data then gets serialized to JSON and embedded in the HTML as a script tag. When the browser loads and React hydrates, it reads the same data from that script tag to initialize its state, no redundant API call, no flash of empty content during hydration. This pattern in static data requirements, server prefetch, client rehydration from serialized state is exactly what Next.js implements with get server-side props and get static props. Understanding it at the implementation level makes those framework conventions obvious rather than magical. Let's step back and look at what the three-stage build achieved, because this is the complete picture of universal JavaScript. You have a single codebase. The same React components run on both the server and the client. The routing logic is shared. Express uses the same route definitions as React Router on the client. The data transformation functions are shared. The validation logic is shared. Write once, run both places. The server's job at request time is, determine what data this page needs, fetch it, render the React component tree to an HTML string with the data preloaded, embed the data as JSON in the HTML, and send the complete response. The browser gets a fully rendered page instantly. SEO crawlers see real content. The browser's job is, display the server-rendered HTML immediately, download the JavaScript bundle in the background, hydrate the React application using the embedded data as initial state, take over routing for all subsequent navigation. The performance characteristics are compelling. Time to first meaningful paint is fast, just HTTP round-trip plus server rendering, no extra API call. Subsequent navigation is fast, single-page app with client-side routing. SEO is good, real HTML at request time. The trade-off is complexity. You're running Node.js in production, not just serving static files. Your server must have a React rendering path. Data fetching must be coordinated between server and client. Caching strategies become more nuanced. But for content-heavy applications, news sites, e-commerce product pages, social platforms, this complexity is justified by the user experience improvement. It's also why Next.js has become one of the most widely adopted React frameworks. It packages exactly this architecture into a framework with conventions that handle the coordination complexity automatically. Understanding how it works underneath makes you a much more effective user of it.